So who am I? My name's Nigel Weber, as you can obviously read. I work for Cisco on the research and efficacy team as a malware analyst. So our team is primarily tasked with vulnerability and threat research, as well as creating content detections for those vulnerabilities. So the topic we're going to be discussing today is registry abuse, and specifically Cls Id or class identifier and com object abuse. So if everybody can hear me, I will start explaining the registry and some of its inherent permission issues. So if you're not familiar with the registry, the easiest, most human readable way to look at it is through the Registry Editor program, which is installed by default on the Windows operating system. So when you first look at it, it will look like this, and each one of these folders is actually called a hive. So it's hive key, classes root, and so on. So by default, the registry has almost no permissions or security built into it. And the registry is essentially a giant data dump that all programs, including the Windows operating system programs, will read from verbatim and blindly trust whatever it says. So why is that an issue is because an attacker can go ahead and write to the various hives in there, and if they know that there is something like a Windows operating system program reading from it, they can replace an important file with their malware, and it will be run with system privilege. So it's a very cheap, easy way to get yourself privilege escalation as well as persistence. So the little permission or security there is built into it is that the HKey classes roots and HKey local machine hives do actually require administrator permission in order to write to them. And the reason for that is that those two hives contain global data that is readable across any user or session logged into the system. The other three, however, are related to the currently logged in user. HKey users just stores all users, but in order to modify any other users' keys or data in there, you have to be an administrator. But you can freely modify your own data in there. So why that matters is because there's actually something called an order of search vulnerability in the registry, because it's up to the program reading from the registry to pick which order they want to read from these keys. Some programs, and this includes plenty of the Windows operating system programs, will actually read from the lower privilege hives first. So if you're an attacker and you can figure out that it's going to be searching a lower privilege one first, and you know that it will actually execute what it reads there, all you have to do is stick in the path to your malware, and that will be what's executed before it bothers to check the class's root or local machine hives. All right, so now we'll actually talk about the class identifiers themselves. So if you're like me, and you're looking at when this is the first time you're looking at them, you're probably going, what the heck are these long strings or GUIDs that I'm looking at? And if you saw it on the command line, and something is being executed in conjunction with this, how do you go about determining what that means? So what are Cls IDs? They are class identifiers, and they're unique identifiers that will point to a specific COM object on the Windows operating system. And they can also be installed with new programs. You can have more of them. And as a defender, why this is a problem is because most of them are good, but any single one of these can be bad. Any single one can contain malicious data. So it's not like you can just write a detection for a single one and call it a day. So then can I write a generic detection? And it turns out that's not really that easy to do either, because the Windows operating system very regularly runs system processes with these as an argument. So, all right. Why is that an issue, or what can you actually do with that? So I believe in showing rather than telling. So I'm going to do a quick demo for you guys here as to what you can really do with the Cls IDs. So the easiest way to do that is to fire up PowerShell, and I'll run it as administrator just because privilege escalation is not really in scope here, and it's not particularly difficult to get yourself elevated up to administrator. And just going to run a handful of commands here. This first one's not actually relevant to the first demo, but it will be relevant later. Okay. All the fun of the M's. Oh, good. So much fun when copy paste doesn't work. There we go. All right. So now for the magic to actually happen. So by magic, we've now launched Calculator. So for those of you who aren't familiar, launching Calculator is the most common thing that people will do when they're attempting to run an arbitrary program as a proof of concept demo of an exploit. And Calculator could be any malicious program like. So let's have a bit of a closer look as to how did I actually fire up Calculator here. So looking at the command lines, on the first line here, we are creating a new object of type GUID, and we're using this GUID here. We'll look into that in a minute as to what that GUID actually is. The next command we do is that we're now deriving the type, and we're saying that it's a type Cls Id or class identifier on that particular GUID. Next is that we actually, from that type object, we actually create an instance of whatever that object type is. And last but not least is then that particular object exposes a run method that allows me to specify a string or a path to program, and it will then happily run that. So to begin, let's say, what is this particular GUID? And we'll come back to the registry here to search for it. Oh, sorry, conveniently in the search. Oops. That's a bit much. Okay, I guess I can either go from 100% to 200%, but some people were telling me that it was a little bit too small. So let's go into the registry here. So by default, we can see, by default, we can see that this particular GUID or CLS ID, the default data for it says it's the Windows script shell host. So for those of you who aren't familiar with Windows script host shell object or just WScript, what that is it's a script interpreter that is installed by default on the Windows operating system, and it allows you to run various script types as well as execute arbitrary programs. So now we'll have a look at what some of the subkeys for that particular key are and what they mean. The first one being the implemented, first one is the implemented categories. And in my research and experience, I've not actually seen it being used in practice. I'm sure that it does have a purpose, but as far as the exploits and this particular vulnerability goes, it is not relevant. The next one that is the most important is the inproc server 32 key. And much as the main Cls Id itself, the default value is the most important. It specifies a path to an object or executable, in this case, the Windows System 32 wshom.ocx file. And OCX files are a specific class of executable. So that's what's going to be executed is the W script object. The next one is the threading model. And unless you're going to be reverse engineering this particular file or binary itself, it's not particularly relevant, and it's quite in detail and technical to get into. So we'll leave that off for the sake of brevity of this demo. The next key that is interesting is the Prog Id or program identifier. And again, the default data is usually what's important. It specifies wscript.shell.1. And the Windows operating system natively understands this string. So you can run wscript shell much the same way as I just did with the Cls Id, but using this instead. Not all Cls Ids will have this program ID. It's usually only things installed by default. The next is the programmable subkey. And much like the implemented categories, I've not seen it used in practice. As you can see, there's actually no data set in here. Typelib, much the same. And then version independent program ID is a little bit less common than program ID, but it works the exact same way. And again, the Windows operating system natively understands this string. So if you're like me or most programmers, you think to yourself, well, that took a long time to actually look up that data. Isn't there an easier way to automate it? And there is, but there is a bit of complexity in there, as there is with anything in the Windows registry. And that's because there's no rigidly defined structure. It's up to the program reading it to pick the subkeys it wants to read and interpret that data as it pleases. In my findings, though, there was I divided into two types of important subkeys for these Cls Ids. And the two were the direct subkeys, such as the improc server 32 or the local server 32. And the 32 is not always at the end of that string, but either one of those keys, as well as the shell key, will point to a program or executable that will be run, some kind of path. And so it's just a matter of actually having automation to sift through those keys and find the important data. The other ones that are important are the redirection keys, such as the treat as key here. And why those can be very frustrating is if you see this particular Cls Id on the command line and it's executing something, but you come in here and you go, well, that's weird. It doesn't have a local server improc server 32 key. It's not identifying any path for something to execute. How is it executing something? Well, the treat as key, as we can see here, has the default data of another Cls Id. So the program will actually then follow that redirection, go to this Cls Id and read to see if it actually has some program or path specified. And you can do this multiple times. So I've actually seen three different kinds of redirection keys. There's the treat as, there's persistent add-ins, and persistent add-ins registered. As far as being unstructured goes, I have actually seen other types of direct execution keys, such as scriptlet URL. Now that one was used, I've only seen that ever used or interpreted by one program, namely the certutil utility that is installed by default on the Windows operating system. So next we will discuss how did I actually know from that object that there was that run method to run that particular string. So in PowerShell, again, this is why it's the most convenient, is you can use the get member, or I call it get methods, but it does have other functionality in other circumstances. You can use the get methods to list out the methods supplied by that object. And in this case, we can see the run key. And why that's important is not simply just because it has the word run. It could be called, my abracadabra function. But why it's important is that it has this string argument here, which means that you can pass it an arbitrary string. And as long as you can figure out what is going to, how that string is going to be used, you can try and then figure out, this is where you get into reverse engineering. You can see, is that string going to actually end up executing something? And for anybody, if you want to take a second to look, see if you can figure out what other ones of these functions might be usable as an attacker. See, I've got a few people asking me to try and increase the size of console. Don't actually know how I can do that. I'll try and make it bigger when I'm back at the demo. Okay, good. Thanks, Ben. So anyways, if you guys were looking, obviously the exec looks like it also takes a string, and exec sounds like it might be executing something. Same with the reg delete, reg read, and reg write, is because those will allow you to directly modify the registry. And again, because you can see they have the string argument in them. So let's do a quick check to see if exec or execute will work the way we think it does. All right, let's try the magnifier here again. All right. So we were to do object4.exec. At object4. So we can see that we then again have calculator. Close that out there. So the interesting sort of thing when we run exec is that it actually knows that it's running as a conv object, which is just kind of a neat little detail I thought I'd share with you guys. But as we can see, it executes exactly as expected. So we'll come back to the demo here, and can't we get the information of that instantiated method list, as well as can we get the data from the registry? And in fact, we can. I wrote a bit of a tool for this because I actually ended up exploring a bunch of different kinds of malware that were abusing this. And so the tool I wrote will tell you this is the particular CLS ID I just looked at. Here's what I think the human readable title is. Oftentimes it will just be the default key in there. However, sometimes there will be no apparent title and it will just be a blank entry then. I will then also tell you, here's what the interesting subkey I found was, and the object path. So then we will have the instantiated data if you so choose to give it the time to instantiate, and it will list out those methods for you. So can we automate this? Couldn't we just go through the entire registry and find all of it and be done with this forever? And sadly, no, for a number of reasons. The first most obvious reason is that Microsoft likes to update the Windows operating system, which includes registry entries. So you will have to run this in order to keep up to date with the most recent keys. You will have to run this on a semi-regular basis. But unfortunately, it takes a very long time to actually go through the entire registry, and that's because each one of those hives has anywhere from 1 to 40,000 of these CLS IDs in there. And then if you want to actually instantiate the objects, as opposed to just listing out the static details in the registry, each one of those objects on average takes half a second to 10 seconds to instantiate. Some of the objects can take as long as, the longest I've seen was 35 seconds to fully instantiate it. If you multiply that by 40,000, suddenly you've got a very long time on your hand, spanning as long as a day. And you also have to completely leave the system alone, because a lot of those objects that are getting instantiated are very low-level utilities and functions that only the Windows operating system should ever really manage. So if you start mucking around in there and you're still playing around with the user interface, you're quite likely to get a blue screen, and then you'll just have to start all over. The other thing that's sort of complicated is those redirections I mentioned before. You can have redirections chains, so it doesn't just have to, you can't just redirect once. You can redirect, 5, 6, 7 times if you want, but you can also branch. You can have 2 redirection keys in the same CLS ID. So then now you have branching. So how do you figure out what it's going to actually specify? And there can also be loops in these redirections. So you have to start having recursion and management of that recursion to make sure you're not in an infinite loop and stuck in there forever. And finally, how do you actually determine that, have I found all of them? Have I found all of these CLS IDs? Because most of them are in very specific subkeys or folders in the specified hives. But these CLS IDs can be hidden virtually anywhere in the registry. So how deep do you want to actually go in? Are you willing to go 5 subkeys deep to find all of them? 10 subkeys? And it is quite common to get as far as 10 subkeys deep into the registry. So there's a lot of considerations as to how thorough do I want to be and how quickly do I want the results. All right. So we already kind of went through the CLS ID and the various keys. Just to show you some of the other ones that you can see is there's stuff like default icon, instance, shell folder, and I've spent many hours going through them. So I found the most common ones, but you can very easily, depending on the program reading it, have important data in there. So that's another consideration for the tool is what do you actually want to be reading out? So now I'll give you a bit of a demo of the tool. Where's my mouse? There it is. I'll just have to unzoom this for a sec. So next off, God, I hate VM sometimes. There we go. Alrighty. So to fire up the tool, we're again going to launch the command prompt as administrator so we don't have to deal with any sort of permission issues. All right. And can everyone see that okay? All right, sweet. So just as a demo, let's grab that. Let's go grab the WScript shell. Plop that in there and see what it says. So we can see that it lists out the static data from the registry. That took literally a split second, but we don't have the instantiated data. So why is that? So I built the tool such that if you want to run it, you can just pass it the H key, which is the most common for help. And then it will tell you that you can view all the settings with S or start adjusting them with A. So let's go ahead and adjust the settings. We'll also show you them. And we can see the reason it didn't instantiate it is because that is currently set to false. So let's go ahead and set I to true. And the instantiation time is in hundredths of a second. So we're giving it 0.3 seconds currently to instantiate. So now we're done modifying that. So let's try pulling out the data from that key again. So again, we see that there's no instantiation data, but it specifies that there is an instantiation timeout, which means that 0.3 seconds isn't actually long enough for the WScript object to instantiate. So we're going to have to modify the instantiation time. Let's give it 3 seconds. And try that again. So we see now that it was given a longer amount of time, it can happily instantiate that. That's why it takes so long, 12 hours for this to go through a single hive. So I'll now show you, just as a quick demo, we'll go put it in quick mode. So I can give you a demo of it actually parsing through the entire registry. So we'll turn off instantiation, so that it didn't take forever. Put search mode to quick, which is just that it will only search for redirect keys within the same hive, not go into other hives. And then we're done. So now to parse through an entire hive, and it's currently set to the H key class's root key, you can just type parse. And these are just little outputs to let you know that it is still chugging along. When you're running the instantiation and it's been running for the last 30 minutes and you're not sure if it's in a loop or still running, these can be very helpful to let you know where I'm currently at. And it will give you some little interesting, if not quite errors, but just warnings about what's going on, such as it detected a loop on this key. So you're probably not going to have any meaningful data coming out of it because it had to terminate execution of its analysis on that one. So that particular hive has a little over 17,000 keys in it. And if you just want to statically go through it, it takes about 13 seconds. Whereas I know from experience it would take about 12 hours to go through it if you were giving it 3 seconds of instantiation. So just a little fun tidbit for you. Tyler, I see you've got a question. I will get to that at the end, because that's actually a very interesting question. So where was it going with that? Right. So I actually listed out, because you can save the output from the searches. I actually have one saved where I did do the instantiation. So let's see if we can find anything interesting there. So in here, such as the run or execute, another interesting one you can often find is open. So we'll do a quick search for open, an open method where it accepts a string. And we can see that we do have an object that matches that. It's called the win HTTP request component, and it gives you a specific version of it. And essentially, so it's the win HTTP com or communication.dll. So if I had to hazard a guess, this would probably let me open any given URL. Well, that's fantastic if I'm an attacker. How do I go about leveraging that? Still VM nonsense. All right. Nothing ever wants to work when you're actually doing the demo itself. All right, that's why I have my little cheat sheet here as well. Take some of the fun out of surprising everyone. All right. So what have we actually done here is we've taken this object, again, instantiating it in the same way. And then we're actually going ahead and we are running a get on my URL, which, if you guys remember, I specified way long time ago. And I'll come to why that's important as a defender later. Then I go ahead and send it. So what can I actually do with that? Well, who knows what data I actually got, but what if I was to do this? Well, that's kind of interesting. Once again, I've got calculator, but I haven't even specified a run. So what have I done this time? So this particular time, I have actually gone ahead, instantiated the object, and I've loaded, yeah, I'll go ahead and magnify it. I thought you might say that. Okay. So I've opened this URL and I've got some data back, which you can actually read as response text. And IEX is a shortcut for invoke expression in PowerShell, which is very similar to, say, run. Well, okay, that's fantastic. So I've executed something from this URL. What is that URL? So we can see up here that it was an HTTP GitHub, and it was calc.ps1. So let's actually navigate there in our browser and see what is available there. So we can see that literally all that's specified there is the PowerShell command start process calc.exe. But it's literally as easy as that to execute commands remotely on the system simply by using these COM objects. So it's not even something that has to be on the system. You can specify other commands to run and download your payloads on the fly. So as a defender, why is that an issue? Well, I specified the my URL maybe 20 minutes ago, but if you were an attacker, you could specify that specific variable of the my URL. You could define that, or as an environment variable, hours or even days in advance. So as an incident responder, if you're coming in and, well, you can see that it opened the my URL, so it was probably getting it from a URL, but what URL is it? And then you'd have to go back and sift through days and days of data, days and days worth of command lines to actually track that down. So this particular exploit is actually a very low complexity attack. And I'm actually surprised at how uncommon it is for this attack to be used. So is it actually used in the wild? It is. The most notable example I can recall was Squibbly Do. And I believe that was about 2 years ago is when that came out. And it specified a Cls Id with the scriptlet URL. And it allowed certutil to download and execute a remote payload. So it is in the wilds, and you can find plenty of examples of abuses for it. So that's basically what the Cls Id objects are, and that was the motivation for me to write this tool to go through the registry and help automate finding these potentially vulnerable objects. So that's all I've really got for today. If anybody has questions, feel free to ask. Otherwise, I can sort of dig into my code a little bit and basically just do a brag of how great I think my coding style is. So when I ran calc, that would be executing, I think that one would just be executing as an administrator, because the W script shell doesn't by default run with system privileges. That one's a user, like a user utility, but some of the other ones such as CMSTP, bits admin, and so on would have system privilege by default. Usually how you get it is because the operating system would be the one launching the command, and then in its normal execution, it would read one of these Cls Ids to figure out something else to run. And that's how you get the privilege escalation out of them. So for your question, Tyler, have I found any race conditions or denial of service vectors by creating the Cls Id? Not with the loops specifically. The loops are usually quite safe, and the reason you get into the loops is because there is no meaningful data specified. And those keys just don't appear to be run. What I think probably ends up happening is maybe when you install the Windows operating system, it originally had some important data there, but it was like one-time use, and then it just cleared out some of those important keys. But you can totally have race conditions with those objects. That's actually why it'll blue screen and why you basically need to leave the system alone when it's running this, is so that the objects don't collide. So Lewis, you said there's different ways to hide the CLS IDs in different hives. Allow branches to take place. What do you mean by branches to only take place when a specified user? Allow branches to only take place when a specific user. So if I understand your question, Lewis, I think what you're asking is, okay, reference your order of preference, sure. If you put it in the lower privilege ones, then yes, that's correct. So you could log in, and the person could even have administrator, like an administrator password or something. But then because if you put it into a key where you've elevated yourself up to system, then you could happily write that same data into either the H key local machine or the H key class's root keys. And then you would have that same execution for all users. So that's how you get the better persistence out of it. And that's one of the big reasons to get the privilege escalation in this way. So H key, yeah, the problem is H key CU. Was that just trying to clarify for Lewis, Tyler? I'm not sure I understand that question. Okay, great. Anybody else have questions? I see, are we just about at time here, or do we have another 10 minutes? Is there any defense to this? Still have 10 minutes. Okay, sweet. I'll keep answering questions and then we can get to code later. Is there any defense aside from Microsoft actually just redesigning the registry? Not really, because again, it's a matter of how do you specify which keys to monitor or defend. It's just a giant data dump. It's just a giant dump of global variables. How do you defend against that? About the only way you really could, it's more like you would just have to monitor for it. The defenses would be more, should any of my Windows utilities actually be downloading any, like connecting to GitHub or to a Google Storage API URL, things like that. So they'd be more generic defenses. When it comes to actually running these CLS IDs on the command line, basically all you can really do is just have something that alerts you that it's there, or also try and notice that some of these CLS IDs or app IDs are being modified in the registry. So that's why I think it's such an interesting class of attack, is because there really is no easy way of defending against it, aside from trying to tighten the privilege or security on the registry. Which sadly has to come from Microsoft. Yeah, no problem, Ben. It was kind of in the same boat as you when I first dug it out, because I just saw it on like one of these GUIDs on the command line, and I was like, how is that actually executing malware? It's really quite interesting. Yeah, so if anybody else has questions, feel free. Otherwise, I'll just sort of start tooting my own horn here with some of the code. I'll just sort of highlight how I went about it. And because, like I said, there is no strict structure for the registry, I tried to make it fairly modular. So if you want to add a new key in, it's quite easy to do. And yes, to your point, Nick, I am surprised that it's not being used more often because it is such a low bar of entry. One of the reasons I think it might be less commonly used is that you do actually have to have a certain level of skill to track down these kinds of vulnerable keys and then figure out how to use them. Most malware authors would just rather have you click a phishing link as the administrator, and then it will download and execute a problem, or send you a malicious Word document that's just going to do the same download, some payload, and execute it. Is the Cls Id different on every Windows system, Chris? No, they are not. By default, the ones that come pre-installed with Windows will be fairly similar between, so any Windows 10 would have pretty much the exact same keys. There might be some added ones if you had, say, the Enterprise Edition or something, but you won't have different keys for the same one. I think even Windows 7 is quite similar to Windows 10. Maybe back in XP and Vista, you might notice more differences because there'd be different objects and different versions of them. But they do tend to be fairly static. If a malware author goes ahead and creates a brand new Cls Id and defines it, that one will obviously be completely unique on the system. So come into the program here. So the first thing I did was I just call it advanced modules, but it's anything else you would want to do besides just instantiating it. Say you wanted to not only list the methods, but also try executing each one that will accept a string passing it something. You could assign that in this particular class here. Probably zoom in. This is a little bit smaller, actually. I don't know, I can't remember how to use Visual Studio these days. It's been a long time. Yeah, so one of the interesting considerations I had to do when I was actually instantiating these is that sometimes instantiation will fail. And I tried having all sorts of error logging or catches for the errors to try and stop it from crashing the program. I guess the COM objects crash in kind of a unique way. So I wasn't actually able to do that. I actually had to spawn a separate process for each one of the instantiations, which also probably adds about maybe anywhere from 1/100th to 1/10 of a second onto the instantiation time, which sadly also increases the time it takes to run. To your point, Nels, is the code available? I don't have it up on a GitHub now. If people are interested, you can feel free to ping me for it, and I'll probably, if more than 1 or 2 people ping me, I will just set up a GitHub for it so people can pull it. I did just design the tools just for some research. There's nothing like super proprietary in there. The hardest thing was just getting the registry parsing working at the beginning. And then once that was there, it was pretty easy to start designing the keys, or like the separate key handlers, such as the direct key handling, where I have specified a list of here's the important keys that can specify something. And then if they needed special handling, so such as the shell key, actually you have to dig through 3 sub keys to actually get to the interesting one. There's just a couple of little if statements for it, and then it'll just go to a separate method to handle that particular key. And the redirection worked much in the same way. That one just had to have some extra considerations for loop detection, and branching. So then when it would branch, it was a best effort to try and pick which is the most interesting key. So generally speaking, local server is more interesting than in-proc server, which is also more interesting than the shell key. So if I had to pick and sort of choose which one would most likely be executed when there's multiple, I would use sort of that order to pick it out. I've done any research into reserves Cls Id shortcuts and folders similar to the legacy folder in COM1. So to obfuscate data. Researching custom right-click menu. As far as the custom right-click menu, yes, I have mucked around with those. They work quite different. Well, I shouldn't say quite different, but they work a bit differently. And it would have required probably at least 50% as much code again in here to sort of parse through those. I found those ones were less consistent in what sort of execution you could get out of them. So that's why I didn't write the tool to handle those as well. But yes, you can absolutely run all sorts of fun things with the right-click menus too. So you can specify like another open. So like when you right-click and it's like, oh, do you want to open something? Or view, like you can specify another one, just rename it the same, and somebody would accidentally click the first one being your malicious one, and it will do something bad. As to reserved Cls Id shortcuts and folders, I don't think I'm actually familiar with those. If you want to send me an email about those later, I would actually be interested to discuss those a little bit with you. I do know, so I didn't really dig into it. There actually, I half lied when I said there's no permissions in the registry. There is also the SAM node in the registry editor. You can't actually even see it, if I remember, unless you're running it as system. So I would have to escalate myself up to system to even show you the SAM node. But that one you can't modify or even read unless you're system. Windows thumbnail rendering. I think I know what you're talking about, but I'll ping you about that one as well. That sounds interesting too. So just I guess a quick question for the B-sides organizer. Is my Cisco email available for people, or should I just drop that in the channel? If anybody wants code or wants to discuss anything related to this, because I actually find it quite interesting, and I by no means claim to be an expert or know everything about these sorts of COM abuses. I just found like the easiest, kind of lowest bar to entry ones. And I sort of stopped there because I realized that it was used quite infrequently. So there was no need to go too deep for detecting these. We just have kind of generic detections to tell us that there was potentially an abuse used. And then we can write more specific detections for specific ones that we see. Go ahead and drop them in the chat, sure. Yeah, so it looks like we're just about up at the 10:20. If anybody has one last question, we can probably answer that, or if not, then I guess we'll wish everybody a happy Friday and enjoy your weekends.